In this video, we'll tackle the issue that quietly causes more failures than almost anything else: moisture. You'll understand why wood shrinks, why buildings move after they're finished, why settling is usually the wrong explanation, and how professionals plan for movement instead of fighting it. We'll also cover defects, grades, and tolerances, including knots, checks, splits, warp, and decay, and how experienced builders decide what to accept, what to reject, and where placement matters more than perfection. And finally, we'll answer the question that separates experience from habit: when solid wood is the right structural choice, and when engineered wood, steel, or concrete will outperform it quietly and reliably. Once species are chosen, however, there is one factor that overrides size, type, and species if it is misunderstood. If you understand nothing else about wood, understand this: wood moves because moisture moves. Not because the carpenter was careless, not because the building settled, because moisture entered or left the wood after installation. Moisture content is not how wet wood feels. It is the percentage of water inside the wood relative to its dry weight. When lumber is cut from a tree, it contains a large amount of water. Some of that water sits freely in the cell cavities, some of it is bound within the cell walls themselves. This distinction matters because wood does not begin to shrink until bound water starts to leave the cell walls. The point at which all free water is gone, but bound water remains, is called the fiber saturation point. Above that point, wood does not shrink. Below it, dimensional change begins. That is the moment movement starts. Framing lumber does not arrive dry. Green lumber carries very high moisture content. Kiln-dried framing lumber is drier, but still far wetter than the conditions a finished building will maintain long-term. This is normal. This is expected. And this is why professionals plan for movement instead of denying it. Understanding moisture content turns wood from a mystery into a predictable material. Wood does not shrink evenly in all directions. Its movement follows the structure of the tree itself. Shrinkage along the length of the grain is minimal and usually insignificant. Shrinkage across the grain is where problems appear. Radial shrinkage, which moves across growth rings, is moderate. Tangential shrinkage, which follows the curve of the growth rings, is the greatest. This uneven behavior is why boards cup, twist, and warp. It is not random. It is directional and predictable. Professionals do not try to stop shrinkage. They design so shrinkage does not cause damage. They orient members intentionally, allow room for movement, and avoid trapping wood in assemblies that cannot tolerate change. When buildings move after they are finished, this is almost always the reason. Wet lumber is framed, the building is enclosed, heat is introduced, moisture leaves the wood shrinks, finishes reveal the movement. This is not a mystery, it is physics. In multi-story buildings, every floor plate shrinks, every wall plate shrinks, every joist dries. Individually, the movement is small. Together, it adds up. Shrinkage compounds vertically. This cumulative shrinkage is why stairs crack away from walls, windows bind, and doors drift out of alignment. These are not foundation failures. They are moisture stories. Calling this movement settling is convenient, but misleading. Buildings do not settle significantly unless there is a foundation problem. What actually happens is that wood dries, dimensions change, finishes reveal what was always going to occur. Professionals account for this by leaving clearances, using slip connections, sequencing finishes carefully, and allowing drying time where possible. Ignoring shrinkage does not make it go away. It only delays the moment it becomes visible. Fasteners do not stop wood movement. They redirect it. As wood dries and shrinks, nails loosen, screws lose clamping force, and connections shift. This is expected. Professionals choose fasteners and connection details that tolerate movement instead of resisting it rigidly. Over-restraining a moving assembly does not eliminate movement. It forces it to show up somewhere else, often as cracks, splits, or squeaks. Professionals design joints that forgive shrinkage, select fasteners appropriately, and avoid rigid detailing in assemblies that will inevitably move. This is not weakness, it is control. When moisture behavior is understood, most common wood failures stop being mysterious. cracked drywall at ceilings and corners. Nail pops, cupped floors, squeaking floors, binding doors and windows, split trim. These failures are not rare. They are common, and none of them are mysterious. They are moisture stories with predictable endings. Professionals prevent them by assuming lumber is wet, assuming it will dry, and assuming it will move. They allow acclimation time, delay finishes when possible, choose lumber sizes that tolerate movement, and design joints that forgive shrinkage. Moisture control is not a single step. It is a system involving storage, sequencing, ventilation, enclosure timing, and material selection. Wood does not fail because it moves. It fails because movement was ignored. Every piece of solid wood is imperfect. Professionals do not try to eliminate defects. They learn to identify them, understand their impact, and decide where they are acceptable. In construction, a defect is not about appearance. It is any characteristic that reduces strength, stability, or predictability. Knots interrupt grain continuity. Small, tight knots away from critical stress zones are often acceptable. Large knots, loose knots, clustered knots, or knots in tension zones can significantly reduce strength. Location matters more than size. Checks and splits form as wood dries. Surface checking in large timbers is often acceptable. Splits that reduce cross-section, occur at bearing points, or intersect fasteners are not. Warp appears as bow, crook, cup, or twist. Minor warp can be corrected in framing. Twist is rarely tolerated. Professionals reject twisted members immediately. Decay is never cosmetic. Even small areas indicate moisture exposure and loss of strength. There is no such thing as minor rot in structural framing. Grades describe allowable defects and structural capacity, not beauty or lifespan. Professionals allocate higher grades where loads are critical and accept lower grades where redundancy exists. Tolerance is not guesswork. It is experience applied consistently. Professionals never choose materials in isolation. Every project eventually asks the same question: is solid wood the right material here, or is this the point where another system performs better? Solid wood excels in short to moderate spans, repetitive framing, and systems that tolerate natural variation. That is why it dominates single-family homes, low-rise residential buildings, decks, and small accessory structures. Engineered wood is chosen when spans increase, deflection limits tighten, and predictability becomes critical. Steel framing is used where moisture exposure, fire resistance, or dimensional stability dominate. Concrete systems take over where loads are extreme, spans are long, and movement tolerance is minimal. Most real buildings use hybrid systems: concrete foundations, wood framing above, steel used selectively where needed. This is not compromise. It is optimization. Professionals do not choose materials emotionally. They choose them based on spans, loads, movement tolerance, moisture behavior, construction reality, and long-term maintenance. Knowing when not to use solid wood is just as important as knowing how to use it. Solid wood is not a default choice. It is a deliberate one. It performs exceptionally well when loads are understood, sizes are chosen conservatively, species are selected intelligently, moisture is respected, and defects are managed instead of ignored. It fails when predictability is assumed instead of designed. Professionals don't rely on rules of thumb. They rely on behavior. Once you understand how solid wood actually behaves, it stops being mysterious. It becomes honest. And when materials are honest, buildings last. Thanks for watching. If you want the full picture, make sure to watch the earlier videos in this series on solid wood foundations and behavior. If this content helped, like the video and subscribe. More professional level construction guidance is always coming.